Today we're going to be talking about Module 1, Lesson 7. So the objective for this lesson is to demonstrate the commutativity of multiplication and practice related facts by skip counting objects in array models. So let's go ahead and get started. Okay, so our fluency practice for today is going to be review talking about arrays. And remember, from last week, an array is just an organized way to draw a picture for multiplication. So if we look at this array on our screen, so let's go ahead and say the total as a repeated addition sentence. So let's think about how we'd find that. So within this array, we have two rows or two groups, and in each group there are 4. So to find the total, I can do my skip count by 4s. So I would have 4, 8. So for my repeated addition sentence, I would have 4 plus 4 equals 8. Okay, so if I took that and put it into a division sentence for 8 divided into 2 equal groups, I would write 8 divided by 2 equals 4, because I'm taking our total and dividing it by the number of groups we had, which was 2, and there were 4 in each group. Okay, but then we could also take 8 divided by 4, because 8 divided by 4, which was the number in each group, to get 2 or 2 rows. So we could write it either way for this array. So that's just review, something you need to remember from last week. Okay, so look at the array we have down here in yellow. We have 4 rows of 2. So if we were to skip count to find the total of that array, we would have 2, 4, 6, 8. So we would have 4 rows of 2. So then we skip counted to get 8. So our multiplication sentence for this array is 4 times 2 equals 8. And remember, that multiplication symbol can also mean groups of. So saying 4 times 2 is the same as saying 4 groups of 2. So what if we were to take the problem we just did, where we did the 4 rows of 2, and what if we turned it on its side? Okay, so here's the one we drew. Now what if we turned it like this? Do we still have 4 rows of 2? Not anymore, because if you remember with rows, they go side to side like this. Okay, so if we look, if we look at this array, now how many rows do we have? Okay, now we have 2 rows of 4. So let's go ahead and think about that. So for our first array, we had 4 groups of 2, which was equal to 8. But then if we look at this array, we ended up with 2 rows of 4. So what do you notice about the multiplication sentences for these arrays? What do the 4 and 2 represent in each of these arrays? Well, let's talk about that. So in this array, in array A, the 4 represents the number of rows, or the number of groups, because if we look, there's 1, 2, 3, 4 rows. What does the number 2 represent? Well, the 2 represents how many are in each row. So if I did my skip count, just like I did earlier, I would have 2, 4, 6, 8. Okay, over here for this array, what does the number 2 represent in this array? Well, the number 2 in this array represents the number of rows now. So then what would 4 represent? 4 would represent the number in each row. So for my skip count, I would have 4, 8. So now let me ask you this. In both of these arrays, did the meaning of 8 change? No, it was our answer for both arrays, for both problems. So the factors, and remember from our last couple of lessons, the factors are the two numbers that you multiply together. So in these problems, 4 and 2 were our factors. So the factors can switch places and trade meanings, but the total stays the same. And that is something we call the commutative property. Everyone go ahead and say that back to me. The commutative property. That's what we're talking about in our lesson today. Okay, so now let's go ahead. We're going to draw an array that shows 8 rows of 2. 8 rows of 2. So this is a good practice for drawing those arrays. So here's a row of 2. We need 8 of them. Here's another row of 2. Another row of 2. Another row of 2. We have to keep going till we have 8. Let's go ahead and do that. Okay, so now we have 8 rows of 2. So let's go ahead and write a skip count to find our total. So for this array, I would be skip counting by 2. So let's go ahead and do that together. 2, 4, 6, 8, 10, 12, 14, 16. So my total would be 16. All right, so we've done our skip count, so now we need to write our number sentence to represent the array. Okay, so our problem for this array, we're going to multiply the number of groups by the size of the groups to get the total. So how many groups or rows do we have for this array? We have 8 rows multiplied by 2. So 8 groups of 2, and we did our skip count, so we found that our total was 16. So we have 8 times 2 equals 16. Okay, so the first factor in our array, the 8, represented the number of groups or the number of rows. Can the 8 also represent the size of the group? So if the 8 would represent the size of the groups, what would our array show then? Would our array look the same? No, it wouldn't. The 8 would represent the size of the groups, so then our 2 would become the number of groups. So we would have 2 groups or 2 rows of 8. Okay, so then we would have 2, just like our last problem, we would turn the array on its side. So would our total change? Would that 16 change if we were to change the 8 to the size of the groups and the 2 as the number of groups? No, it wouldn't change because we would still be able to skip count by 8s. So we would have 8, then 16, and that would still be our total. So let's go ahead. I'm going to go ahead and draw that array right here for you to see what I'm talking about. So right here we have 8 rows or 8 groups of 2. So if I were to draw, so here's one row of 8, 2 rows of 8. So that's taking this array right here and just turning it on its side. So then I would do my skip count by 8s and have 8, 16. So instead of having 8 groups or rows of 2, this time I have 2 rows of 8. And they would both equal the same thing. So just like on the last problem, that's where we're using our commutative property, and that's saying that the factors, or the two numbers we multiply together, can trade places in a problem and still have the same answer. Okay, so we're going to go ahead and move on to our problem set. We're going to do a few problems together. So let's go ahead and look at number 1. Number 1 says, draw an array that shows 6 rows of 2. So let's start there. 6 rows of 2. Okay, so here's one row of 2. So keep going till we have 6 rows. It might be a little tricky to fit in, but just do the best you can. 1, 2, 3, 4, so I need 2 more rows. I might even have to make this a little bit smaller. 4, 5, 6. That was kind of tricky to fit in. Okay, let's go ahead and do our skip count for this array. So I'm going to write the skip count next to the row. So we have 2, 4, 6, 8, 10, 12. So part B says write a multiplication sentence where the first factor, so that would be this one right here, represents the number of rows. Okay, so if we look back at this array, we know we have 6 rows. So then our 6 would go here. So then we would take 6 times 2, because the 2 represents the size of the row. And when we did our skip count, we found out that 6 times 2 was 12. Okay, so that's all they're looking for on that problem. Let's go ahead and look at number 2. Okay, number 2 says, draw an array that shows 2 rows of 6. Okay, so we had 6 rows of 2 over here. Over here, we're doing 2 rows of 6. Do you think they'll look the same? Let's see. So 2 rows of 6. So let me go ahead and draw my first row and my second row. Okay, and if I did my skip count for that problem, I would be counting by 6s this time. So I have 6, 12. Okay, so it says write a multiplication sentence where the first factor represents the number of rows. So for this array, there are 2 rows. And in each row, we have 6. And after we did our skip count, our answer was, or our total was 12. Okay, so let's look at these 2 problems. Are the arrays look the exact same? No, they look different. Were our factors in both problems the same? Yes, we had 2 and 6. Was our total the same? Yes, it was. Okay, so even though the arrays in this problem looked different, okay, we drew them differently, our factors and our total stayed the same. Okay, so I'm going to go ahead and stop this recording because I'm going to need to split it up into 2 smaller recordings. So I'm going to go ahead and stop here, okay, but go back to Seesaw and there should be another video for you to watch for part 2.